Hi everyone, this is Callum Blair here at Knox Academy. I'm the head of maths. Welcome to the third video in the series of videos looking at key aspects of first year maths. In this video we're going to be looking at multiplying and dividing by 10 and also multiples of 10. So for example, multiplying by 20, 30, 40 and 50. We are going to first of all have a very quick look at something called exploding dots that we look at in various ways quite early in S1, and the link to what will be to us a familiar method for multiplication. We will then look at using a TechnoChat to multiply and divide by 10, and then how we can use that to solve some other number problems. We will then look at how we can use a number slider to multiply and divide by 10, and then lastly multiplying and dividing by multiples of 10. So without further ado, let's have a look at exploding. So this is something that we like to do, partly for a bit of fun and partly to check for understanding. So exploding dots applies to adding, subtracting, multiplying and dividing, and it's useful from the point of view of making sure that pupils are really comfortable with what we would call the traditional and the familiar methods, and can give good explanations about why we do the things that we do. So in this case, we are using a number machine. And in this particular number machine, you can't have more than, you can't have 10 or more dots, in a section of the machine. So this is what the machine looks like. And basically it's the place value columns. So we've got units and tens, hundreds and thousands. So something that we will be familiar with. We have to complete the calculation 134 times 3. So we've got 4 units, 3 tens and 100. Now in terms of this idea of exploding dots, we'll see that in a moment. We need to multiply 134 by 3. So there are 3 groups of the 4 units, 3 groups of the 3 tens, and 3 groups of the 100. So what we can start to see in the units column is that we've got more than 10 dots. We've got 12 dots in the units column. So essentially what happens, because the rule is that we can't have 10 or more dots in a section, is that 10 dots explode, and their equivalent is 1 dot in the column to the left. So those 10 units become 110. In the 10 section, we now have exactly 10 dots. And again, the rule says that we can't have 10 dots in a section at a time. Those would have to explode, and the resolution is for that to go into the immediate left column. So those 10 tens have just become 100. So this is an idea and a concept that we play about with early in S1. So the answer here, of course, then is 4 hundreds, 0 tens, and 2 units. So 402. The reason that I've included this in this particular video is this idea of multiplication and moving to the left. So moving to the left. So that's a concept, and that's a little thing that we'll talk about a little bit later on in the video. So just sliding to the left, those groups of tens exploding, and then an equivalent dot going into the column to the left. It is as well a visual of what I would probably call the traditional way of multiplying. So if we take the same problem, 134 times 3. There's the initial setup of how we might lay that out. Then we've got what would be the equivalent to explosion number 1. 3 times 4 is 12, but of course we cannot have 10 or more in one section of the number machine, or in this case one column. So 10 explodes and goes into the next column. And that's essentially how we would lay that out. The second explosion, that would be 3 times 3, which is 9, add the 1, which is 10, and of course we cannot have 10 dots in one section, or in this case one column, so that has to explode and move into the next column. 3 times 1 is 3, add that 1, of course, is 4. So there's the 402. So hopefully you can see the little connection. And in the next video, of course, what we will be looking at is different methods for multiplication. And this column approach isn't necessarily the preferred method in the department. And I'll explain more about that in the next video. So that's a very quick look at exploding dots. Remember, the reason for its inclusion is this idea of sliding to the left. We'll now introduce the TechnoChat to multiply 10. So here is one of these charts. Essentially, we've got different columns or different blocks in this chart, using the number 1 on the left-hand side, then the number 2, 3, 4, 5, 6, and 7. 8 and 9 would normally be included too. So essentially what this does is it's taking the digit, the 1 or the 2 or the 3, and making use of the place value columns. Let's have a particular look at the one involving the number 5. Going up the chart, each step up the chart is a multiplication or by 10, and each step down the chart is a division by 10. So this concept we encourage people just to become really familiar and really fluent with using the chart and without using the chart. Use this diagram to help you answer the following question. 50 times 10, well there's the 50. Each step up the chart is a multiplication by 10, so that would be 500. Lots of young people could do that calculation, of course, without the use of the chart, which is fine. But we would encourage it to be talked about and to talk through and to be part of explanations. 500 times 10, again, we're going up the chart one step, so that would be 5,000. Very quickly, we're able to introduce decimals here, and pupils tend to prefer working with whole numbers compared to decimals, as it is in this case. So that's where the chart does become particularly useful for a number of young people. So 0.005 times 10, we're up the chart one step to 0.05. This is where, of course, the misconception that when you multiply by 10, you just add a 0 breaks down, which is why we wouldn't talk about that in a classroom. Okay, when we multiply by 10, we don't add a 0. When we multiply by 100, we don't add 2 zeros. That's not something that works all the time. And we do want to work with concepts and methods that work all the time and work throughout the curriculum. So 50 divided by 10, we're dividing, so we're going down the chart one step. So 50 divided by 10 is 5. 5,000 divided by 10, 500. 0.05 divided by 10 is 0.005. So again, the chart becomes or comes into its own when we start talking about decimal numbers in particular. And it gets people really fluent and really familiar with these types. Take, for example, a little exercise like this, that if you wanted to work through, you could pause the video now to do that. what we're doing is encouraging the pupils to think about the number of steps, how many multiplications by 10. So in the example A that has been done for you, 5 times 100 is the equivalent of 2 multiplications by 10, which of course is 2 steps with an answer of 500. We could then extend it. So we're not talking about efficiency here. We're not talking about the most efficient way of thinking about it or doing it. We're thinking about different ways. So we're kind of probing for pupils' understanding here. So multiplying by 1,000, for example, is the same as 3 steps up. So there's the illustration of 3 steps up. Okay, so how could we write that calculation in another way? Well, I've put there in purple brackets 10 times 10. So I know that 10 times 10 is 100. So that's another calculation that answers the original question, 0.05 times 1,000. So we're encouraging pupils to group their multiplications of 10 and just think about it in lots of different ways. Okay, again, that's not only checking for understanding in this particular learning outcome, but it's also checking for understanding that they know that when it comes to multiplication, you can group you can have subgroups within your multiplication. So in this case, it's the 10 times 10 in the purple bracket. And sometimes noticing these subgroups makes the calculation overall easier. And that's a topic in itself when it comes to S2 maths, is having a look at these multiplication groupings to encourage young people to spot and to look for these types of question and these types of opportunity. So again, we might look at asking pupils on whiteboards, for example, or in their jotters to look at these 6 calculations and write them in 2 different ways, and as well as, of course, finding the answer. So again, returning to the TechnoChat, we would then mix it up. We've primarily focused just on the number 5 at this stage in the video. We want the young people to obviously be familiar with all of the sections of this chart. So not only using 5, but using 2 and 3 and 4, for example. So again, you could pause the video at this stage if you wanted to work through some of these questions, checking your answers, for example, in your calculator on your phone. We would explicitly address a misconception like this. John says to multiply by 100, we add on 2 zeros. Is John's statement always, sometimes, or never true? So this allows good opportunity within the classroom, again, to probe understanding, to check for understanding and have really good discussions within the classroom, to encourage pupils to come up with their own examples that prove or disprove their own statement or someone else's statement. And that really opens the floor within the classroom to have these discussions and specifically address something like this. And of course, John's statement would sometimes be true. For example, 5 times 100 is 500, so it does look like we have added 2 zeros, but we would encourage the explanations to be 2 steps up the chart, for example. So in terms of solving other number problems, well, again, another good stretch challenge, another good extension is a problem like this. Write how to get from 0.02 to 400 in 3 steps. Those steps can involve multiplication or division only. So for example, we're working with the number 2 section of the chart. So there's 0.02. If I multiply that by 10, we go 1 step up the chart to 0.2. Okay, right, so I'm now at 0.2. If I multiplied that by 1,000, we would go 3 steps up the chart, up to 200. Okay, so I'm now at 200. We can multiply by 2 to get to 400. So again, there are more efficient ways of doing that. For example, instead of multiplying by 10 and then immediately after multiplying by 1000, we could have done that in one step and multiplied it by 10,000. The point in this activity, or the value of this activity, is the fixed number of steps that we are applying here. So we're not looking necessarily for the most efficient method. That could be a conversation after presenting something like this. We're looking to encourage pupils to really reflect and think about how they could process this question. So for example, instead of multiplying by 10 and then 1000, other pupils might come up with the fact that you could multiply by 100 and then multiply by 100 again, and then multiply by 2 at the end. So there are lots of variations, and it's in many ways it's quite an open problem. Again, 0.08 times to 400, this time in 5 steps. So we're looking at the number 8 section of the chart. So 0.08, okay. Let's divide that by 100. Let's move down the chart 2 places. Okay, what could I do next? We could multiply it by 10. So that would be one place up the chart. So there are so many opportunities within this task for pupils to practice this idea of moving up and moving down the chart for any given number of steps. So 0.008. Okay, what could we do with that? We could times it by 1000 and move up the chart 3 places. We could then divide by 2 to make the 40. So the 40 is now looking a bit more familiar in terms of working towards the 400 target. 40 times 10 would be the 400. So there's my 5 steps. Again, there are several ways. This is only one of them. So you could maybe try a couple yourself or ask your child to have a go at this task. And here are some more examples that could be useful to try at home. So we've talked about using the chart an awful lot, and we would like our pupils to be able to do calculations like this one, of course, not just using the chart, but in their head. So we want pupils to have a real visual of what these types of questions would look like and how we would do them. The number slider is also a really useful resource to multiply and divide by 10. Has sets of these. There's a teacher one which is slightly bigger than the one the pupils use, and you can see in the image on the right hand side that we would take the whiteboard that sits inside and we would just slide it to the left. If we were multiplying by 10, one space. At the bottom of the right hand side image, we can see when we're dividing, we slide it down. And that's quite a useful resource for pupils to use in the classroom, and it provides another visual model, particularly when we have more than single digit numbers. For example, in this case, 53. So if we took a number like this, 5.82, pupils would write it in the space in the whiteboard, and then we would multiply by 10. We would slide it up. We would slide it to the left one place. Again, there's that idea that we talked about with the exploding dots, that sliding to the left when we're multiplying by 10, because of course that would mean that each column, because it's been multiplied by 10, would have groups of 10 in it, and they would all explode and all move to the left. 67. Again, pupils would wipe the whiteboard clean, pop the 6 and the 7 in, multiply it by 10, slide it to the left. Of course, in this case, we have to add a 0 into the units space. There should always be something in the units space. 7.82 multiplied by 100, we're moving up 2 places, we're moving to the left 2 places. Using the chart, of course, that would be moving up 2 steps. So 782. It works very well for division as well. 5,000 divided by 10, we would slide that down the chart. And in this case, we would slide it to the right of the slider. We wouldn't leave the answer as 5,000, 0.0, that 0 in the 10th position, that 0 to the right of the decimal point would be rubbed out to just 500. 14.5 divided by 10, slide that down 1 place on the TechnoChat, or slide it to the right on our whiteboards as we're looking at them. The answer would be 1.45. A really common thing to talk about, and it's certainly something that I heard, was about moving the decimal point. Where you can see here within the place value system, the decimal point is fixed. It has just as fixed a position as the hundreds, the tens, and the units. We don't change those. That's fixed. The decimal point is 2. So we don't talk about adding or removing any zeros. We don't talk about moving the decimal point. We always talk about the movement of the digits. And if we can hook that on something like the exploding dots and how that helps with this movement to the left in particular for multiplication, all the better. 3.78 divided by 10 would give us this. But again, we're coming back to the fact that there always needs to be something in the units position, so we need to put a 0 into that position. We couldn't just write the answer as 0.378. The 0 would need to be there. Something to use at home. There are a couple nice websites. I suppose this one looks a little bit childish, but it does highlight the concept pretty well if you wanted to do some practice at home. It's topmarks.co.uk, and you would just search for moving digit cards and this would come up. Alternatively, on the mathsbot.com website, you can type in, so for example here I've typed in the 4605, and you could be asking your child to do whatever you want with them really, so multiply by 10 or divide by 10, and then use the little arrows at the left and the right hand side to physically make those moves and to check the answers. So on the mathsbot.com website, you would click on the Tools tab, which sits at the top, and then look for the place value chart. So lastly, we're going to look at how we would multiply and divide by multiples of 10. So numbers like 20, 30, 40, and 50. In this case, we're going to look at 32 multiplied by 700. We could express it in a little sort of number machine diagram, I suppose. We're starting off with the 32. To multiply that by the 700. Now we would break that up. We would encourage the young people to break that up. We would hope and we would teach them to notice that 700 can be split up into 7 times 100. The timesing by 100 part of this is really important. We know that that's 2 steps up the TechnoChat, or it's 2 slides to the left on our slider. So we're looking to make the calculation as easy as possible. So 32 times 7 would be 224. Pupils could handwrite that and show their working, and we would have that on our whiteboards in the classroom. 224 times 100, we would hope, is something that pupils could do, or most pupils could do in their heads, thinking about those slides, and some people could still be using their slider. That would be up. So there we go. There's the 32 times 7 making the 224. And the 224 times the 100 is 2,400. Here's another diagram for 32 times 700, fill it in. Okay, well, we're starting off with the times by 100. So it's the same steps, if you like. We're timesing by 7, we're timesing by 100, but multiplication is what we would call commutative. We could do it in any order we want. So for example, 2 times 5 is 10, 5 times 2 is 10. So we can play about with the order and still get the same answer. So 32 would be 3,200. 1,200 times the 7 make the 22,400. We have here a little exercise that we would present the pupils with. So if you wanted, you could pause the video now and try these questions before I review the answers. So in part A, we've got 25. We're going to multiply by 4 and then by 10. 25 times 4 is 100, and 100 times 10 is 1,000. In B, we're starting with 7.2. We're going to multiply by 6 and then by 10. 7.2 times 6, having shown a little bit of working, would be 43.2, and 43.2 times 10 is 432. So it's one slide to the left. 32 times 200, we would break up the 200 into times 2 and times 100. 32 times 2 is 64, and 64 times 100 is 6,400. And lastly, we have 5.4. We're going to multiply by 300 by multiplying by the 3 and then multiplying by 100. So 5.4 times 3 is 16.2, and 16.2 times 100 is 1,620. We can also do the same for division. So take this number machine here where we're working from the left to the right. If we were doing division, we would want to reverse those steps. So starting with the 22,400, how would we work it back to 32? Well, reversing the to divide by 100, and then apologies about that, we would get 224. So 22,400 divided by 100, as highlighted on the screen, is 220. Well, here the next step, of course, would be the opposite of the times by 7. We would by 7. So 224 divided by 7 will work us back to the original answer of 2. So in this case, the top diagram is about multiplying by 700. The bottom diagram is about dividing by 700. So we're still using the same sort of factors, the 7 and the 100. But how we use them to multiply and divide is dependent on what the question is. So take this division here, for example. You could pause the video at this stage and give that a go. Part A, we would divide by 10 and then divide by 4. Alternatively, you could divide by 4 and then divide by 10. Both would work absolutely fine. In part B, 720 divided by 10 and then divided by 6 would be the division by 60. So 72 would be the division by 10, and 72 divided by 6 is 12. 32,000 for part C, we're going to divide by 100 and then divide by 2. 32,000 divided by 100 would be 320, and 320 divided by 2 is 160. Again, here's an example of a worksheet we could use in the classroom, sort of a fill in the grid, which is often quite popular and does require an awful lot of thought. For example, about halfway down that worksheet, we don't actually have the middle column, so pupils need to figure out what that actually was, which involves working backwards from the answers that are given at both edges of the worksheet. So again, you could pause the video if you wanted to give that a little go with your child, and here are the answers for you, which involves an awful lot of reasoning, but a really good understanding of this concept of sliding the digits. What we have is a spider diagram, and we have 45 times 39 equals 1755. And using that fact, we have these 7 other equivalent calculations, similar calculations, and you need to think about what slides have actually happened. So for example, in this one here, we can see that the 45 has been slid one place to the left, or one slide up. The 39 has been slid one place down to 3.9. So you then need to reflect on how those slides will actually affect what the final answer is. So in this case, you can see that it has not affected the answer at all. The one slide up for the 45 and the one slide down for the 3.9 have effectively cancelled each other out. So we have looked at, lastly, multiplying and dividing by multiples of 10. Again, if you want any further work, it's there on the Revision Hub. There's a little section in Phase 1 and a little section in Phase 2. So thank you for listening. I hope that was useful. Please get in touch if you have any feedback.